I've made quite a few modules for my Eurorack, but I hadn't done something with vacuum tubes. Initially, I was thinking a triode-based amplifier, but then I decided on a pentode-based VCA. So I decided on the 12AF6, which is a pentode used in car radios in the 50s. It uses a 12-volt heater and it has a 16-volt plate voltage, so it doesn't need any of the high voltages. And the 12-volt heater means you can power it directly from the Eurorack rails, and the plate voltage means that it isn't in starvation mode. Amplified parts sells the ones for in either the Zenith or the Sylvanas, and I don't think you can choose which ones you get, but they sell them for new old stock for $4.30 at the moment. And there's various replacement alternatives. The VCA schematic consists of 4 parts. There's the input part, the control voltage part, the output part, and the heater. The input is simple. In principle, you could connect it directly to the grid, but you may want to add an high-pass filter, since a DC component will mess with the result. 100K potentiometer for an attenuator is very useful because this means you can have various levels of distortion go through the tube, which is one of the reasons you want to have a tube amplifier. There is an optional 1 mega ohm leak resistor. The results you connect to pin 1 of the tube. I just bought a socket with it that allowed me to wire it, and that had screws that allowed me to hook it up to the panel, so it should be relatively easy. The output section is connected to pin 5. Pin 5 needs a 33K pull up to 12 volts because that is how it makes the electrons flow through the tube. In order to hook that up to the output jack, you want to use another high-pass filter because you don't want that 12-volt component to mess with your output. Ideally, it is sitting at 6 volts, so you have the maximum amplitude. And basically, you could theoretically get 12 volts PP, peak to peak out of it, but in reality, it will be smaller. It fluctuates based on the control voltage. The heater has a 12-volt differential connected to it, pins 3 and 4. It doesn't matter whether you use the negative rail or the positive rail, but don't use both. The CV is the hardest part of the circuit. Initially, I tried it with resistors, like having a resistor mixer and a pull down. Upon measurement, I discovered the VCA will close at minus 8.6 volts, and it will be fully open at 0 volts. Since a CV voltage usually ranges between 0 to 5 volts, at least in my system, that needs an amplification, and obviously you can't amplify using resistors. So I added a TL072 operational amplifier, and for convenience I used both of them in inverting mode, so that first I can sum all the inputs, and then the second op-amp is used to invert it back to a normal signal. Because otherwise your CV will move the other way around, and you don't really want that to happen. So I'm adding minus 12 volts through a 15K resistor for the minus 8.6 volts starting level. Then I have a knob that goes from 0 to 12 volts that I hooked up through a 15K resistor, and that allows me to have an offset. You could opt for minus 12 volt to 12 volt here, and you could also lower the resistor if you want this knob to have a stronger effect on the result. And then the CV, the control voltage, through a 6.8 kilo ohm resistor, so that it gets amplified. So instead of 0 to 5 volts, it will be able to move 0 to 8.6 volts. The grid isn't really happy if it is above 0 volts, so I added a diode to ground that limits the output to 0.6 volts, and of course a resistor to make sure the op-amp doesn't strain to power this diode. And I connected the result to pin 2. Then there's pin 6. This is another grid. You can experiment with it, but I think for the gain that you want from the amplifier, you should hook it up to 12 volts through a 1K resistor for safety, and that will ensure that the electrons move faster and therefore the amplifier works better. I've seen a schematic that uses 0 volts in order to get a wavefolding effect, but for me, this just causes the entire VCA to be very quiet. Finally, there's the ground plate, the cathode grid, which is connected to 0 volts through a 2.2K resistor. When the audio moves, it will try to pull more from this plate. And in order to make sure that it is able to do that, there's a bypass capacitor, which of course allows AC currents to pass easily. I chose 10 microfarads. That's primarily because I can use a 50 volt ceramic capacitor and I don't have to worry about polarity. But in the higher capacitor will filter less of the audio signal. I believe that generally 22 microfarads is recommended here. As you can see, schematic is rather simple and it works with a 6 HP panel. Especially the width of the tube is limiting here. A regular 3x6 protoboard, similar to this one, that you can just get on Amazon with double-sided solderable holes. You can put the whole thing on there. You can plan it out, put the components in there, and then solder it. I like making my modules with only one board deep and have both the knobs and the jacks and the components on that one board because I enjoy a very shallow case that I built a while back. To make the panel, I decided to go with brushed aluminum. Of course, that gives a more vintage look. I am worried about making those panels. I have a jigsaw with aluminum blade, but it is still making a lot of noise. It's important to lock down the aluminum before you saw it in order to prevent it from moving. And similarly, when drilling the holes, it's vital to make sure that it is clamped. So this is the finished module. We have the panel, which is the aluminum that I cut, with the input with attenuator, the CV with attenuator and the output, the prominently displayed tube, vacuum tube, with the socket attached using M3 bolts, because that is basically the Eurorack standard. You can see the electronics, the single layer, the power connector. I have a few components at the back, but no wires, because wires tend to get stuck with everything inside the Eurorack case. Let me undo the top so you can see the inside as well. It is all connected with only the 3 jacks. And I use the hexagonal ones for the output and the round ones for the inputs on all my modules to distinguish the two. And that is the circuit on the inside. You see the TL072 and how I allocated the sockets. I wired everything directly from the tube to the circuit board with relatively color-coded signals. Blue is the output, white are the inputs, and red and black are the ground and 12 volt. And I put some of the components directly on the socket as to minimize the number of wires that I needed. However, you may want to move the knob slightly farther away from it, because although the tube doesn't get hot too hot to touch, it's still unpleasant when you try to adjust the attenuator. Tube will use 150 milliamps continuously for the heater, which means that the power supply of the Eurorack need to be able to supply that.